Hi, this is Khalid Nukh from Navitas. Today we're gonna talk to you about wind simulation using computer softwares, and we're gonna use an example of an incident that happened in July 2018, where a boom crane was working in Al Abdali area. This is Al Abdali area, and the boom crane was actually under operation in one of the projects, which is the Al Abdali Hospital. And while it is actually carrying some weights, it fell down. And this simulation is intended to make us better understand the reasons behind this incident, hoping that this information might be useful for constructors, for companies working in the construction sector, for developers, to better understand the behavior of wind, especially in urban areas like the Al Abdali. Actually, we had to build a 3D model for Al Abdali area, where you can see it now. So this is the full existing buildings with the heights of Al Abdali area. And the incident happened in actually this building, where the crane was in this specific location. And while in operation, according to the operator of the crane, he stated that he was faced with sudden, unexpected wind that created this incident and caused the crane to crash. Of course, there were no casualties, only minor damages in the surrounding area. So to be able to do that, we have built, as we have said, the full Al Abdali area, and we have subjected the model to a wind from the west, west north, west south direction. At that specific time, the wind speed recorded in this area was 20 meters per second, with a gust wind speed of 30. Of course, a gust wind speed is usually a factor that magnifies the effect on the structures or any object that is subjected to that wind. Nevertheless, for the specific of this study, we have only considered a 20 meters per second wind speed. So whatever results we reach to with a 30 gust speed of the wind speed, we expect that the results are magnified and the effect on the elements are actually magnified. So we're gonna share with you some of these results. We will start with looking at the x direction of the wind speed. So this is a section in the wind speed at the height above the podium of the area 1 study. We're gonna zoom in just to show you. I've made it transparent so you can see the below structure of the building, and we're cutting only at the exactly above the podium level. So you can easily see that we have now, this is the wind speed as magnitude. So if we're gonna look at the x velocity, which is in this direction, so you can see now easily that the area where the crane was working was under a low wind speed. Nevertheless, an adjacent part is subjected to a very high wind speed, which means that if the crane is moving only in this area and then suddenly part of it goes into the high wind speed of, which is demonstrated by the yellow color here, then suddenly this would have an effect on the crane. It's worth mentioning actually that if you look carefully at the diagram of any wind speed, you would easily see that some of the areas, we just change that to non-transparent so you can see the colors better. Okay, so if you see here that, okay, the wind speed that we have started with was actually 20, which is in the green area, while the simulation has generated wind speeds which is higher than that. This is simply due to the reason that the tunneling, due to the shape of the buildings in that area, would actually create a higher wind speed, local wind speed, that might reach up to, in our case, 35 meters per second. So from 20 to 35, that's 50% more in magnitude, which is also very dangerous, and we have to look at it carefully. So we go back and we just change that to transparent to enable to see the areas clearly. And as we said, so there is a part easily that you can see that the wind speed in this area is higher, extremely higher than this. So now if we look at the, as we said, this is in the X direction. So if we look at the same thing but in the Z direction, which is the vertical direction, you can also see that we have in this specific location, due to the shape of the building, we have an uplift wind, which is also a high altitude compared to the other areas. Going back to the X direction, let's add to our analysis a vector, so we can see now the direction that we have for the wind speed. So this is becoming more interesting now. So actually in this blue area, and due to the shape of the building and the orientation of the wind, we see that the wind is actually coming from the east side, while in this part is coming from the west side. So if we have any crane in this area where part of it is in this yellow area and the other part is in the red, or sorry, the blue area, then this creates a twisting effect or force on the crane, forcing it to move in one direction. Adding to that, as we said, the vertical direction, then we end up with a very interesting also. So if we look at the vertical, okay, here we can see the vertical direction. So if we have the section, vertical section in this area, it clearly shows that we have a high wind speed going up in the vertical direction. So this is now getting us to understand more what's happening in this specific location. To be able to see this in a better view, let me just switch these off and go to what we call a trace. So this is actually a trace of the wind. So if we have a wind coming in from this direction to this specific model, now here it shows us what is happening with the wind. So if we go closer, you can easily see that in this specific location we have up wind coming from here and then going up. So if we look at it from this side, so you see now the turbulences created by the shape of the building, okay, creating an uplift turbulence in this specific area where the crane was working. So if you look at it from this side, you can see it now. Okay, we believe that this is the reason behind the incident that happened last month, where this crane was subjected to a turbulence, was working in one area, and then part of the crane, which we expect was working in under the blue area. Let me switch on again the horizontal. So the crane was working in this area with a wind coming from the east direction and a low wind of about 12 meters per second. When part or the top of the crane went into the yellow area, it was subjected to a wind from the west, while the other parts was subjected still under the east direction wind. At the same time, we had an uplift force, wind force, coming on part of the crane. So these forces together created the event where the crane was had to fall down. It wasn't really accounted for during the operation. We're sharing this information on our social media platforms, hoping that this would create more awareness for engineers, for crane operators, for contracting companies to understand the outcomes of wind tunneling in an urban area, hoping that we will avoid having such incidents in future. You can contact us if you need more information. We're ready to share the full details of our analysis with anybody who is interested to know more about this specific case or any other cases. Thank you very much and have a nice day.